Hi, there's a group of us following along with Paul McWhorter's Raspberry Pi PicoW lessons, and we're on lesson number 3. Um, I've been following Paul for quite a while, plus I've probably got 12 years in electronics and Arduino. So um, Paul's been teaching us Python. So um, I've done, this is my 3rd class with Python for it. This time we were working on the PicoW, so micro Python, but it all the same. And but since we've been around for a while, Paul asked some of us that might consider these to be like beginner lessons, not to get discouraged and follow along with him and maybe try helping other people out. So uh, instead of redoing the homework for this, I'm gonna try to help out another fellow that posted some homework. Um, our homework was to create a 4-bit binary counter with LEDs, and um, this fellow James, he came up with went out on the internet, looks like, and found some great code, and it looks like he modified it. I don't know whether it was for a Pico in the past or whatever, but it looked like it was for MicroPython. So but he did a great job getting it going and everything. And when he was explaining his code, he kind of stumbled when he got to this and sign, and maybe not knowing exactly what it was doing. So I thought that maybe I'd make my video and maybe discuss. I see 3 things in this program that are probably something that you'll learn a little bit later on in your coding career and on your coding journey, not career, but your journey. Anyhow, the 3 things I see are, he got hexadecimal numbers that we haven't talked about yet. This and sign, which is actually a bitwise and, we'll talk about that. And then when our count gets down here, we got this little percent sign, and it's the modulo operator. So I'm going to try to touch on each of those 3 things, probably concentrating on bitwise and the most. So Paul was talking about binary numbers today, and showed us examples of binary, and then comparing it to our normal 10 base numbers. Binary is 2 base, and regular numbers are 10 base. And he actually showed a fictitious 3 base numbering system. Well, these are called hexadecimal numbers, and they're actually base 16. So to be able to get it all in one character, they go 0 to 9, and they go A, B, C, D, E, and F. Each one of them can hold 16 different digits. And and then if you're reading this, the first 2 things, 0x, is just telling you that what comes next is going to be a hexadecimal number. So this is actually just a hexadecimal, 2-digit hexadecimal number, and they can go from 00 all the way up to FF, and FF is actually 255. So if you've been around for a little bit, you know that 255 is the highest number you can get in an 8-bit byte. So they use this hexadecimal to represent bytes sometime, just rather than 255 or something like that. It's just a different way of using it. The way it's used here is really not necessary, because we're not using the hex value so much. We could have put decimal 1, 2, 4, and 8, and it would have worked, or we could have put the binary representation of each of these, and Paul showed us how to do that. So it could be 4-bit binaries there. And so that's all I need to say about that. If you want to look more about what hexadecimal numbers are, you can certainly go out and Google it. So this next thing is a little bit more different. This is the bitwise and what the I guess I I tried to find some Python resources on it, but I learned it way back in Arduino days, and I think they have some of the best documentation on the Arduino site on that. So if I'll leave a link in here, but if anybody wants to learn about bit math, it doesn't matter whether it's with the Arduino or whatever. But this is a really good comprehensive thing on bit math. So I'll leave a link down there. So a bitwise AND is what you're doing is you're comparing two binary numbers, and starting from the right and going to the left, you're comparing each two different numbers. So, and with a AND, the only way that you're going to get a result of 1 is if both of the ones in that column, the characters in that column, are 0 or 1. So a 0 and a 0 is going to give you a 0. A 0 and a 1 is going to give you a 0. A 1 and a 0 is going to give you a 0. And a 1 and a 1 is going to give you, just for, they call this a truth table. So you have other bitwise, you got AND, OR, XOR, and all these other ones. And each one of them has a truth table. So just to see the bitwise OR, the truth table for that is that you are going to end up with a 1 if either one of them is a 1, right? So 1 and 1, 1, 1. And then, like I say, you got other ones, exclusive OR and not and everything. So, but we'll go back to our AND, because that's what that code was doing, was an AND on it. So, like I said, they were just taking the 4-digit numbers and binary numbers and doing an AND on them. So I was going to try. I don't have a drawing pad for my computer, and I was going to try to type it on a Word document or something like that. I said, I think it'd be easier for me just to write a Python program to show what's going on with it. So let's see if this is going to work. All right. So what we're doing is we're going to put in 2 binary numbers, and then it should calculate the results. So we put 0, 0, 0, 1, and then we put 0, 0, 0, 1. So remember, only time it's going to be a 1 in the column is if it's both 1. So we should end up with a 0, 0, or 0, 1 when we do this. And that's what we get. So let's change this, and let's say, what if we put 1, 1, 1, and we put 0, 1? So, and then what if we get the same answer if we had a 0 here? What if we put a 0 here, it would do that. And like you say, if you do the math, the only time you're going to get a 1 in your bitwise AND is that. And you might think, well, why did we want to do it that way? And why did they use that? So let's go back to James's code, I guess. You can see it pretty good here. So James's code, so you have your count and you're bitwising it to a 1. So, but remember, when we put this value here, we're trying to send a value to this pin, and it's either it's a digital value, so it's either going to be on or off. So if the result of this calculation is 0, 0, 0, 0, which is 0, that's going to be, off. But if you do this calculation and you get a 0, 0, 0, 1, that's the same as a 1, and it's going to be on. So, and then you're calculating for each bit in the, see, these numbers are different. So this is actually the rightmost digit. This is the second from the right, this is the third from the right, and this is the fourth from the right. So each one of them is doing that bitwise and on it. So I figured just to show that is, let's see, I got to turn this one off. So I did another program to show how we can do that. All right. So here, this is more or less what we're doing on your program. And so this hexadecimal is equal to this. Like I say, each time this hexadecimal is equal to this, hexadecimal is equal to that. So now if we put a number in, and I'm going to put it, I made it so I can put your incremental numbers in. So if I put a 1 in there and calculate it, so your 1 is a decimal there. So we're doing the bitwise and on these two numbers, and this is for the first LED. And to get a 1, your lead state for that first lead is going to be 1. All right. But then leads, you're doing it because the math here comes up all zeros, it's going to be off. All zeros going to come off. All zeros going to be off, and all zeros are going to be off. So your lead state is going to be whatever the calculation in there is. So let's go back and let's say if we got a 2 in there and calculate it. And lead 1's going to be off, but lead 2 is going to be on. 3's off, 4's off. So, and what if we go to 3? So we got that, so we know, and then, but we got this lead state on because it's a 1, but we got this, and this is, oh, this should equate to 2. Well, how's that work? Because all we're looking for is a 0 and 1 on our code. So let's go back to James's code. So the value coming up in here, like I said, we're doing this one here, and we're coming up with a 2 for the value here. The good thing about programming languages is when they're looking for a Boolean value, an on or an off or something like that, they accept 0 as off and anything else is going to be on. So a 2 is okay, a binary 2 or a decimal 2 or anything, or a decimal 255 would be same thing. It's going to turn this on. It doesn't actually have to be a 1. So that's a good thing to know. So, but anyhow, let's go back to our thing here. So let's say if right now, so now we got the lead is on, this leads on, and the other one's off. So we go up to 7. And now we got on, because it's not 0. Anything that's not 0 is going to be 1. But lead 4 is 1. So then if you go to 8, you got 0, 0, 0, and then 1. So that's how you're going to get your lead states. So his code, the code that James has here, is just doing this math. And like I said, it doesn't matter what this number here is. If it's not 0, it's going to turn the LED on. So anyhow, so go back to his code a little bit. So that's what
I set up a time to sleep.
Put him on there. There we go. So the code here is that's what this bitwise and is doing. It's deciding whether each LED is on compared based on, you know, the bitwise and that it's doing here. So, and we're incrementing down here, and I don't know, this is called the modulo operator down here, and we have 256. So the modulo operator, what it does, well, we got a plus equal, so we're going to do our math here. And it's whatever the count is, it's going to add 1 to it. So what this modulo 256 does is allows it to roll over. So if it becomes once it gets up to 255, the next one's going to be 256, and it's going to if it's going to take the remainder. So this modulo is also the remainder. So it's like dividing by 256 and taking just the remainder. So let's say if you got your first time through and you're adding one, you got one and you divide by 256, it'll go in 0 times with one left over. So that's what your count is going to be the one. And it's going to do that all the way up. But then when it gets to when you got 255 and you're adding this one to it, you get 256. So you get 256 divided by 256, and then all of a sudden you get, it goes into it one time, but your remainder is 0. So only thing this is returning is the remainder. So count is then going to be 0 again, and then it's going to go through the whole process again. This is just a easy one-line way of just counting through a certain set of numbers and everything. So that's fine. But I wondered why it was 256 here. And then I noticed this space in here. And I have a feeling, I don't know what he did up here, but I have a feeling that this code probably originally had 8 different LEDs on it. And they would be, the next bits up for each one of these, because like I said, if you remember that with an 8-bit number, you can count to 255. So that's so it's, but we're only actually counting 0 to 15. So you may wonder, well, why does it keep blinking over and over again? And we can actually go and show that that we are actually only concerned with the 4 lower digits on the binary number. So let's bring up our thing again. So like I said, we can go up here to 15, and that way we got on, and on. But now the code is going to keep counting all the way up to 256. So we could go up to, we can just go to 16. So the next time through it's going to be 16. But we're only keeping track of 4 bits. So you can see that we're not even worried about what this one up here is doing. We're ignoring it basically. And if you look for 16, you got 0, 0, 0, 0. So they're all, the 4 lower digits are off. And so, and then, then when you would go to 17, you got the 1 again, but then the 0, 0. So it's just like you're just ignoring anything past this thing. So if you go to 255, 255, and that's 8 all ones. And then if you roll over the next day, if you go, you can't really roll over, but your code's going to go back to 0. But as you can see, if you do your bit math, we're only doing the bit math on the 4 lower ones. So you're getting 1, 1, 1, 1. And then, like I said, when you roll over, you're going to go back to 0 again. So anyhow, that was the 3 things in James's code that thought might be a little bit farther along the coding journey, but I tried to explain them. Hope it helped a little bit. If not, I tried. Okay, I'm going to consider this my homework for lesson 3, because I'm not going to light up any leads for doing that. Anyhow, thanks for watching, and I hope and somebody got something out of this. Thanks for watching.